Okay, so we're back. Sorry about those technical issues. So that'll occasionally happen as I just figure this out. So the key question is we're calculating the variance here of d, and so this is the variance of this sum of these xi's, and so the key question is, can we bring the variance inside this sum? And the answer in this question is yes. And again, this is something that you'll slowly get used to. And this is not because of linearity of variance, because the variance is not a linear operator. This is actually because of independence. So the only reason we can bring this variance inside the sum is because of independence. And so now we need to calculate the variance of xi. And then you might recall that that is p times 1 minus p, and that's something that we'll cover briefly in the next lecture, but so it's approximately 0.24. So the variance of d here is 24. So you can kind of say that if you're looking at the sum, that it's going to be 55. The expected value is 55, and the sum and the variability on that is 24. Now let's look at part B. So recall that part B asked, what's the probability that more than 50% in the people in the sample vote for Democrat. So what we're looking here instead is we're looking at the probability that D is bigger than 50. So in your sample, are there more people voting Democrat or Republican? So here, we in an ideal world we need to know the distribution of D, which we in principle could say it's a binomial and use that approach. But what we're going to do instead is that since sample size is in quotes large, we're going to use the central limit theorem. Okay, and so once again, this is something that by the end of the course of 309, it's probably more in your mind than it is right now. But hopefully over the first week or two, these calculations will start to become more and more familiar because we're using them throughout the course. So by the CLT, which I'll use that acronym quite frequently for the central limit theorem, what we have is that if you look at the sum of the xi's, wait, this should be 1 over 100. I'm sorry. The sum of the xi's divided by 100 minus its expectation divided by the square root of the variance, and then we multiply that by square root of n. That should be a normal 0, 1 random variable approximately. So we can plug all those values in for what we're trying to calculate here. And so remember that D equals. Okay, so we're looking at we can plug in E of xi because we know what that value is. And then we also know that the variance of xi is 0.224, and so if we take a square root of that, this is going to be very, very close to 0.5 is the variance. And so this is going to be, okay? And so we want to find the probability that D is bigger than 0.5. And so what we want to do is to kind of exploit this normal 0,1 approximation. So we want to convert that D into something that looks like this so that we can use the normal table. And so we just want to do all the manipulations to make the D into the form in the line above. And so we can say that this is equivalent to and so whatever we do on one side, we have to do on the other. That's sort of one of the fundamental rules of math. And so that's going to be sorry, this is okay, so I'm just doing this this calculation, and then why we've put it into this form, as we'll see shortly, is that this is just looking at now we can exploit the normal approximation and just say that let's look at a z-table or a z-score, and this is the probability that a standard normal is bigger than -1. So if we draw this, let's draw what a standard normal looks like. Okay, this is, again, we're looking at this area here. So we're expecting a number bigger than 0.5. And you can look this up on a z-table, and this will basically be approximately 0.84. And so that is your answer. So all of these calculations should hopefully ring some sort of bell to you like coming from probability. And again, if it's not super familiar, just just try to use these first 2 weeks to start to familiarize yourself with this, and I will be going through this in more detail in the next couple of lectures as well. Okay, so that's kind of a 309 perspective. So now let's move to more of a 310 perspective. So let's look at, we're still looking at voting in Wisconsin, but we're thinking about it. I'm going to ask you more of a 310 type question. So this is a question that you actually, you may know how to do it in your mind, but we haven't actually learned the tools yet to do it in either 309 or 310. So okay, so this scenario, it may look quite similar to what you saw for the 309 scenario, But as we see, it is actually quite different, and it actually points to the key difference between what we're going to learn in 310 and what you previously learned in 309. So here we have an independent random sample of 100 people in Wisconsin, and they're asked whether they will vote Republican or Democrat. And so we have that 55 people in the sample vote Democrat. So before we had that 55% of people in the population voted Democrat. Here in this scenario, we have 55 people in the sample who vote Democrat. And so if we go right back to the if we go right back to 309 versus 310, in 309, you have a probability or a population model, and then get a sample of or some random variable, some data from that. Here we're trying to go the other way. So we're given data. So we're given that in a sample of 100 that 55 people vote Democrat. And we'll see that all the questions that we ask are going to be related to trying to say what's going to happen in the population. And that's really the more realistic setting in voting, right? We get polling data, which tells you what happens in a sample, and we're going to try to infer what happens in the population from that. So here are the questions that we're looking at. So our goal is to essentially, determine what might happen on election day. Okay, so sorry, another sort of just technical issue. Let me just okay. Okay, so sorry. So all of the questions we're asking here are based on now we're trying to use the sample to assert what's going on in the population. So we're first going to ask for a distribution to model the chance that a random person in the population will vote in Wisconsin will vote Democrat. based on our sample, we want to make a guess at the number of people in the population who vote Democrat. And then we want to attach a standard error to this guess. And then C is we want to, we want to ask the very important question as to, who's going to win that state on election day. So based on your sample, what is the chance that over 50% of people in the voting population vote Democrat? And I put the word chance in bracket here because as you'll sort of hopefully see, this is not actually a chance or a probability. It's something that we kind of like to think of as the closest thing we can think of to a chance or probability. And again, these are questions that we haven't actually learned the tools for, but they're more about setting up what we're going to see in this course. So for part A, once again, sorry again. Sorry, things are getting stuck here. Oh, come on. Hopefully this works better.